So I will start the technical presentation with your permission. And also, it is a totally technical session combined with lot of interactive sessions, interactive questions and answers. Wherever you feel like asking question, you are at liberty to do so that we will consolidate at the end of the day. Okay. So basically, you can see here itself, there are three photographs. The left extreme is a smart meter. I will tell you what is exactly a smart meter, how and when, where it is to be used, etc. All those things also we will discuss. The middle one is a in-home display. I will tell you more about this. This is also known as IHD. This is a attachment to the smart meter, and it is the property of the user, not the electricity board as such. Anyhow, this particular mechanism will give you the data on metering philosophy and also what is actually being consumed, what is being left over, what is the charge for the day. All those things it will tell. We will tell more about it. Don't worry about anything. You please assume that you do not know anything about smart meter. At the end of the day, definitely you will be rich in knowledge of smart meter. That is the presentation focus we have made actually. Okay. And right, we have another picture of smart meter. I will tell you more about it as we proceed further. Okay. So in this presentation, we cover the smart meter challenges, new infrastructure requirement. Okay. Some of the terms, which are defined. We will also discuss about the architecture of the meter and also the AMR technology, which is being used today, advanced automatic meter reading system. Okay. This is not the old one. This is a new one, advanced automatic meter reading system. We will tell you more about it. What is actually the Indian scenario? And also, we will focus on integrated testing of these meters. So in these 90 minutes, we will cover these things and question and answers also at the end of the session. But if you feel like asking question, definitely feel free, because this is the subject which is very important from the national angle. Okay. So let us proceed. What is actually the smart meter performance requirement? As you can see here, the requisites of an ideal smart meters are: number one, accurate registration under all reasonable load conditions. What is a reasonable load condition? It is the condition wherein the load is not distorted, in the sense it is not having any sort of either harmonics or any sort of distortion in the load. It may be a linear load, it may be a non-linear load, but it has to satisfy the conditions laid down by the Central Electricity Authority. Okay. Sustained accuracy for several years with least attention and expenditure. Okay. I have highlighted two factors here. Number one is low internal loss, and also the ability to start on very high light load. We will discuss that actually as we proceed. So we will focus on this low internal loss and also ability to start on very light load. Okay. Apart from these things, the meter shall also be independent due to various external factors like temperature, voltage, power factor, waveform, frequency, and it shall be insensitive to the external magnetic field, insensitive to vibration of support. That means when the meter is being carried from the manufacturer's works to the utility to the consumer premises, it should not be damaged or it should not be inoperational. Okay. So capacity for reasonable accuracy on overload. From the practical physical standpoint, it is light in weight, compact in dimension, rugged in construction, easy to install, easy to test, and simple as far as seamless communication is concerned. We will tell you more about it as I proceed further, because smart meter is something which is related to the communication system, communication engineering technology. Okay. So we will focus on 2 points as I told you in this particular slide. Number one is low internal loss. What is low internal loss? Low internal loss is nothing but the loss in the meter, which should be as low as possible. This is not a metered parameter. This loss is a loss to the utility. Since you are the user, you are the actual custodian of these meters, the more you save here, the more benefit you will get to your electricity department. So that is the main intention here. Okay. And also the meter shall start on a very, very, very small load. What is a small load? We will discuss these two things in the next two slides. Okay. If you have any doubt, please get it clarified. Don't worry about anything, because we are in the learning process, and think that you are learning the great knowledge, particularly with regards to the national importance on smart meters and smart grid. Don't hesitate. Okay. Don't worry. The internal power loss in smart meter. In India, there are about 260 million meters to be replaced, approximately 250 to 260. I have taken 260 as the figure. Each meter will consume around 1.2 loss, 1.2 watts, which is not metered. It is for 24 hours, 365 days, 15 years. If you take the life of the meter, it will consume 409 lakhs 96,800 megawatt hours. Please note this. Very, very important. So with a change of zero point 0.9 watts, that means it is possible by the technology. What we are going to use in the smart meter power supply, that is a switch mode based power supply, SMP we call. The SMP will consume very small power. So because it is basically a circuitry meant for power supply. So it will consume around, say, if you can design the meter in such a fashion that if it takes the overall power loss to 0.9 watts, the loss will be 368 lakhs 97,120 megawatts. Indian standard specification, international specification on smart meter will specify a loss of 2 watts. Okay, when I was a design engineer, almost about 35, 40 years back, actually, we have designed a meter with zero point 0.9 watts and supplied to then AP electricity board, and they were very happy about the performance of those meters. They are all basically, first basic induction meter, and then we went to analog meter, and then we went to hybrid meter, and then we went to what we call a digital meter, and this digital meter had 9.9 watts actually. So with 2 watts, it is 683 lakhs 28,000 megawatt hours. So this is an unmetered loss, possible to achieve through state-of-the-art technology. Even if you take power rate as 5 rupees per kilowatt hour, it will be 20 lakhs 49,984 million rupees. This is the loss to the board. So it is possible actually to focus your attention to make sure that the loss parameter is reduced, and you will be in a position to achieve what you need to be done for your electricity department. It's a huge saving in conserving energy at the national level. You can see right side, there is a small diagram, smart meter. This is the distribution board. Directly it is connected to the mains. The mains, it will first focus on the power supply. The power supply it will consume from the mains actually. And this is unmetered because it is not in the load circuit. It is in the voltage incoming circuit. We call incoming circuit. Is it clear to you? Okay. We will see further. The second one which I highlighted in the requirement is the smart meter capability of converting small loads to tariff. That is mobile charger case. Each mobile phone or charger consumes around 8 to 10 milliamps. Wherever you go, railway station, airport, you just plug and charge your mobile. Okay. And it will consume around 8 to 10 milliamps current. And this current is very small current, and the present meter probably it is not in a position to read it accurately or convert that into a tariff. So even if you take the calculation, 10 milliamps, 260 million meters, zero point 0.4 is the power factor of the switch mode power supply. In India, there are 96 crores 5 lakhs 79,472 charges. This is approximate figure I have taken from internet, particularly LinkedIn. So this is the data available, and this is converted into megawatts. It will be 999.002651 megawatts. And when you convert this into the megawatt hours, it will, because it is actually 2 hours a day, 365 days, and you take 2 years as the life actually, 14 lakhs 58,543. So this is actually the total loss, which is not metered at all, because it is a very very small current. Okay, so you can read further. Okay, and what is the saving here? 729 crores 27 lakhs 15,000 rupees at the rate of 5 rupees per kilowatt hour. So present meters will not convert this into tariff, and it is a loss to the exchequer. Exchequer in the sense it is the agency which supplies the power. Okay, smart meter does it. Even 3 to 5 milliamps will be read, will be converted into tariff. The accuracy is not the question here. The question here is very important. Question here is how this small current is converted into tariff, and this is where our importance of technology and our knowledge pool will help actually to focus on what needs to be done, what needs to be strengthened actually. So India's per capita power consumption is lowest in the world. The per capita electricity consumption reaches 1025 kilowatt hours in September 2021 as per the Central Electricity Authority. Okay, number of mobile chargers. I think these two slides just an introduction, just to keep you focused and just to warm up you. And now we will go to the actual subject. Okay, how we have traveled in the electricity metering evolution. 1885, Ferrari discovered these meters based on induction principle. Okay, and that is the meter which is known as electromechanical meter. Even today in some parts of Andhra, Telangana, all over India, these meters are operational. Do you agree? Okay. Next is the electronic meter based on hybrid principle, based on analog technology, based on digital technology. Today we are living in the digital platform. Okay, and we developed what we call prepaid meter, and that will be focused with advanced metering, automatic meter reading system. That also we will discuss later on. Don't worry about it. So this is the second phase of activity in the traveling scheme. And third is the smart meter and the AMI we are going to discuss actually. That is very important for this particular subject. That is advanced metering infrastructure. So we will see more about these things. So this is how Indian journey in digital and smart energy metering is happening. As you can see, first, Central Board of Irrigation and Power, CBIP, in 1986, it derived what we call a first edition of specification. In 1999, IS 13779 was formulated. And then we started in 2008. For your information, CBIP 1986, BIS 13779, and BIS 13779 1999 modification, I was associated and contributed to this particular thing. Afterwards, before I was in DHEL, there this particular contribution was done. And finally, when we started our journey in 2008, the whole all India government, particularly the Indian government, resorted to what we call RAPDRP, where automatic meter reading system for the distribution transformer feeder meter was introduced. In 2011, IS 15959, that is part 1, where the exchange protocol of energy meter, which was developed jointly by CPRI and also the Bureau of Indian Standards, this was published actually. Contributor was actually basically the committee from CPRI and also BIS, Bureau of Indian Standards. In 2013, Central Electricity Authority issued what we call functional specification for energy meter. Okay. In 2015, that is in 2017 and 15, we developed IS 16444 draft standards, which was coming into practice. And in 2016, IS 15959 was formulated. So like that, we traveled actually. 2014, pilot projects were started actually for smart grid application. In 2015, UDAY, you must be knowing this particular thing, Ujjwal, okay? National tariff policy was formulated for all consumers, 200 kilowatts per month, to be brought under smart metering by December 2019. This is actually the Government of India notification. Okay. And in 2016, ISGF, India Smart Grid Forum, they published what we call as innovative business model for smart metering philosophy. And also different models were discussed, like leasing model, followed by what we call CBA, cost benefit analysis. And in ISGF developed a white paper on what is called Wi-Fi metering. Wi-Fi metering is the latest technology trend. And 2016 CEA developed a notification on AMI rollout, that is mass rollout of AMI, advanced metering infrastructure, was formulated. Okay. And then EESL, a government agency, Ministry of Power, to assist distribution company in smart metering. Okay, in 2020, prepaid smart meters for all customers, 250 million is the base of India, and this is how we started our journey in the smart metering philosophy, digital metering philosophy, and also electronic energy meter to fulfill the obligation of the different versions of electricity boards. What is a digital energy meter? It is based on digital technology, which can also measure other electrical parameters such as voltage, current, active power, reactive power, power factor, frequency, so many other parameters. Okay. And also, the measured data is then will be sent through a communication channel. So, a typical electronic meter consists of what? A power supply, okay, a display LCD, okay, a microcontroller for processing, voltage and current sensor for sensing, the applied voltage, load current, and communication ports. The communication ports we will discuss separately because that is a subject of big importance. And also it will have a real-time clock which will give the actual registration under the real-time condition. Okay, this is a very, very important factor. You have to synchronize the clock with regards to your reference application. So this will have very high accuracy in measurement, greater flexibility, and updating capacity. So we will proceed next. So what is actually a smart meter then? Yes, MART. Yes is specific. M is a measurement, energy measurement. A, which can be attained, real time, R is real, and T is time actually. This is how it is: specific, measurable, attainable, realistic, and timely. Smart. A smart meter is a very similar to the traditional meter on your premises. It measures, records the consumption data of energy. However, the smart meter differs because it is a digital device that can communicate remotely with your utility. Okay, it will send your consumptional information to your utility at regular intervals and eliminates the need for a meter reader. Meter reader is not required. So in addition to reporting your energy usage, the smart meter can inform the utility immediately if there is a power outage or theft in your area. It can quickly dispatch crews, very, very important, to resolve the situation and to get back power as soon as possible. Okay? So once everything is normal, the smart meter will notify your utility of the resolution through a mobile app. So this is how the smart meter what it is. So we will see. We'll go into the all details of smart meter. Don't worry about it. All aspects of smart meter we will cover. Okay, don't worry. What is the main meter requirements of the smart philosophy? Number one is accuracy. Number two is the cost effectiveness, optimal cost. Number three is manufacturability, how easily we can manufacture. Number four is very important, the reliability over a period of time. That means sustained accuracy, consistency of reading, consistency of functionality, stability. All these things are very, very important from the point of understanding the smart metering philosophy. Okay. So this is a slide taken from LinkedIn very recently, probably 10 days back. We have, when formulating this presentation, we were doing this actually. Uh, If you are not a member of LinkedIn, you please send an invitation to me. I will definitely honor it. We will discuss more about smart meters, more about smart philosophy in the LinkedIn platform. Okay. So you understand how it is smart meter in a nutshell. So smart meter records your energy usage, view your spend on the in-home display. Meter readings are automatically sent to your supplier. This is how the sequence actually. Okay. And then you can get an accurate bill. You play online. This is how the whole process of smart meter. In the center, you can see focused one. Smart meter records consumption in intervals of 10 to 15 minutes or even less than that. It communicates information at least daily back to the utility for monitoring and billing purposes. It enables bidirectional communication. That means two-way communication from you to the meter and meter to you. Okay. It provides online update to the user through web or in-home display to help very efficient energy usage and reduce bill. Very important. Okay. Next we will see the right side. You can see a picture of a smart meter, international smart meter. Okay. So it is an AC, digital, technology based, static energy meter, no moving parts, with time of use register. What is time of use register? It is the consumption based on the time of use. As you use, the consumption is recorded into different set of registers. Like what? Peak load, off peak load, semi peak load, shoulder peak load, like that. We can categorize, and each will focus on registration. So it will also have an internal connection and disconnection switch along with a bidirectional communication display. Okay. It can measure flow of forward import or both forward and reverse direction current, energy, storing capacity, and communicate the same along with other parameters. Okay. It can be remotely accessed for collection of data, collection of events, records, and programming capacity for all events records which is happening on the metering philosophy. You can see here a beautiful slide which has been made, from LinkedIn. Okay. This is the left side, you can see home with small devices. Okay. What is a smart device? A smart device is a wired or a wireless context aware electronic device. It is capable of performing autonomous computing and connection through devices for data exchange. Okay. So the right side you can see a smart meter, three-phase smart meter with a communication module. You can see here WAN module. This is a wide area network. I will tell you more about those things. Don't worry about anything now. For the time being, you just see how it works actually. Okay. So you see in a house you have smart devices like what? Smart lighting system, smart AC, smart TV, smart oven, smart dishwasher, washing machine, refrigeration, whatever it is. Okay. It will be communicating through the meter, different technologies, maybe PLC technology, that is, the power line communication. We will tell you more about those things. Zigbee, this is another important communication. Okay. Wi-Fi, this is another communication. Like that, meter will get the whole data from all the loads. If the load is off, no power consumption. If the load is on, at what time? If the load is on, how much? So this is the smart meter. This is what we are to discuss. We will go into all details of this now and open up the whole domain to make sure that this works on the principle of what we understand as the technology solution available for the Indian condition. Smart meter working system. This is a very important thing. For example, consumer, you have, the meter is here. You can see the green color one. One, two, N type of meters. Okay. And this is the wireless channel. That means communication through RF. This is the wireless channel. Okay. And this is the wireline channel. That means wireline channel means what? it is mainly focusing on what we call PLC based system. Okay, so this is the service provider who provides the service, like the communication, like your Airtel, Vodafone, whatever it is. They are all the communication providers. Data service providers. Okay, so here we have the home area network that is confined to home, and also the energy meter gets the signal. Actually, each energy meter will send the signal, and then it communicates and goes to the data system. And then finally, the service provider users, like energy supplier. Okay, so DNO is the distribution network operator who operates the whole scheme, and it goes to others also, others in the sense who are having a stake on the smart metering working principle and working philosophy. Okay, this is how the smart meter system as an integrated solution will work actually. Okay, so what are all the main benefits? As you can see here, number one, on time and accurate billing. Next is near real time information. May not be very accurate because clock synchronization, it depends upon the error. Okay, fine. Optimization of assets, how the asset management is done. Better demand side management, it will manage the demand, particularly the electricity demand. There will be a gap between supply and demand, so this will be met automatically by means of this particular mechanism with which it is possible. Better outage management system, we call the OMI. We will see more about it as we understand. So ATC loss reduction by data analytics. Data analytics is something which is related to the big data which is being projected for the application, because every 15 minutes this gives you data. I will tell you how much data you will get. You will huge terabytes of data it will have. Better consumer satisfaction, customer satisfaction at the end. Use of data in home automation. Okay, and finally it answers the smart grid philosophy. Okay, next. It's a very, very, very important slide, as you can see here. Value delivery from smart meter. Okay, so the previous methodology is utility operation benefited by walk by reading. Okay, walk by reading means you go there, you take the reading, issue the bill. Okay, and the payment will be done automatically by the user taking his valuable time, and then it can be based on the conventional methods of payments, whatever it is today. This is what it is happening today in the present scenario. But in smart meter, because the utility operations are benefited by adopting the smart meters, so many parameters will come into picture actually, because you can plan your load, you can create a smart grid awareness, reliability of execution, efficiency of execution, engineering and engineering details, particularly the technology solutions, data analytics, because it's a big data based on the Hadoop technology, customer service, asset management. You can conserve energy. Renewable integration here is very important, because you can use these meters for as a net meter, which I will be covering actually some next day. Okay, here you are having lot of importance to, particularly with regards to what we call the photovoltaic energy, sun energy installation, wind energy installation, and also biomass. What all those things they come under the renewable category. Billing mechanism, metering, and demand management. Finally, it comes to the question of how the demand is managed. Basic feature, for example, electrical parameter, bidirectional communication. It has a connection disconnection switch. This is a bipolar latching relay, a tamper event and direction and recording, remote firmware upgradation. Firmware is nothing but the main software provided for the application, and also you can upgrade it. And it answers the net metering philosophy, that is the meter which I'm going to talk to you probably tomorrow. We will talk more about net metering, and we'll understand what it is. Communication technology, in fact we will go details actually in one of the presentations, don't worry about it. But however, I would like to discuss what communication it will have. Number one, it may have a radio frequency, RF. It may have a GPRS, maybe 3G or 4G. That is, the generation, third generation, fourth generation. Of course, fifth generation is yet to come in India. The communication technology based on NB-IoT, that is narrowband uh, Internet of Things. It is a cellular, low power, wide area. Low power, wide area. I will tell you more about it. Don't worry. And also, it will have the connectivity. Okay. And then power line carrier communication. This is here, the main focus is on the power line. And also hybrid. Hybrid may be combination of any one of these things actually, either radio frequency plus PLC, radio frequency plus any other mode of application. It will have a hybrid combination. So this is how the communication system in a smart meter works. So this is the block diagram of a typical conventional energy meter. As you can see here, this is the old one, residential, industrial, consumer, conventional energy meter, manual collection of data, manual billing. And here in the smart meter philosophy, industrial consumer, residential consumer, it will have a smart meter, a communication protocol, with which we will discuss more about it. Don't worry. It will have a gateway. Okay, gateway is actually to focus on allowing the whole system to be operated upon. Okay, communication interface protocol, and it goes to the main database with which it is possible for us to analyze and also apply the correction. This is how the smart metering philosophy works actually. Black diagram approach. Are you clear? Shall I proceed? Okay. What are the layers of smart meter? Number one, a feeder will have different distribution transformer. Okay. So a different distribution transformer may have number of smart meters. For example, the distribution transformer here may have about 400 to 500 or even 1000 meters it can support actually. So what philosophy we use here? We use a meter here, we use meters here, and we use the consumer meter here. Okay, the sum of this is equal to the reading of this. The sum of these readings will be the reading of this. If there is any lapse, it is going to have a havoc on the meter philosophy. This is what we call the check side of a feeder metering mechanism. This is a very, very important aspect to be known actually. Okay, this is the layer with which the smart meter philosophy works. Okay, here how the smart meter is illustrative. We can see here. For example, this is actually the smart meter. This is the communication infrastructure, and this is the head-end system. Head-end system is actually a software and also a ICT based networking system which acts as a server actually. Okay, and then it goes to the file. This file is nothing but your integration between head-end system and meter data management. Meter data management, what it does, all those things I will tell you. Don't worry about anything. Please be patient. We will cover everything. Don't worry. Okay. And then it goes to what we call the integration between the MDMS. This is MDMS will get data from HES. HES will get data from the meter and to communication. And finally, it goes to what we call the legacy module metering system and billing mechanism. Here you have the customer portal, app, and then you can get the readings here. So this is what it is. This is nothing but your MPLS, that is multi-protocol label switching. This switching arrangement is nothing but your total communication practice bidirectional. As you can see, double-headed arrow. That means to say it is having the communication between MDMS and the billing mechanism. So this is what it is. What is the product chain from the consumer to utility in smart meter? Smart meters are connected from user endpoint to the integration system, and integration system is connected with the distribution companies, enabling energy accounting and energy data communication. Okay, so you can see here the diagram. Consumer smart meter, interconnecting system which connects between the consumer meter and the distribution company. So this is how the whole thing is banking upon. Next, we have the challenges, main challenges. What are all the main things actually? Number one, the consumer indexing. Indexing in the sense how the consumer is where whether geography is okay, etc. Meter installation, meter is installed, and you advise the user about the pros and cons of the meter, including the communication. Okay, and billing is received, and it goes for what we call analytical solution, we call analytics, and then we'll spend more time on this understanding, because this is the whole philosophy of understanding, the smart meter is based on our data analytics. What is the consumer awareness about smart meter and benefits of smart meter? Number one, consumer must be made aware about the smart meter philosophy when it is installed. Okay, and he will be in a position to make sure that what he does is in line with what is required. So the benefits are what? Number one, error free billing, restoration in case of outages, very fast. Tariff structure, you can have an intelligent tariff structure, innovative we call. Okay, this is also known as smart tariff structure. I will tell you more about it, don't worry. So remote control of loads of customer premises, how we know the control of load is done at the customer premises by what we call the time of the day metering philosophy. Okay, so consumer awareness and benefits. Okay, so ability to remotely manage and control appliances, this is important. And also it is have a potential to save huge money for the electricity board, mainly for focusing on what we call time resorting mechanism. And consumers will also be able to remotely manage and control appliances. Okay, easier grievance redressal if there is any. And also delaying obsolescence, that means you can always focus on software upgradation as and when it is required and as and when it calls for. And also you can have assure that the power quality assessment in a network assessment is to be done to make sure that what you get is the actual what you deliver. This is very important. And what are the main drivers of the national smart metering system? Number one, meter reading. Okay, reduction in misdirected and unallocated payment. So this is a very important factor because electricity board is running into loss because of this. On time and accuracy of billing. Okay, monitoring and reduction of the aggregate technical and commercial losses, which is the subject of the day. Operational efficiency very high, improved distribution companies revenue. Okay, reduction in peak power purchase cost, we call PPP, we call peak power purchase cost. That means the transformer is safe, the overloading is not done. The power quality enhancement and asset optimization is one of the most important factors to be understood actually. Okay, and also human error is not there. Okay, and the reduction in that human error. And time consumption is very important. Further, the drivers are visibility of energy consumption, that means it is open, transparent, and no hanky panky there. Reduced operational expenditure, quality of power, efficiency energy. Okay, emission, this is very important. And we are talking of net zero. That net zero is possible only by digitization. Net zero, that is we recently concluded in the conclave at Paris that India will be in a position to adhere to net zero. So that is possible by reducing emission. Easier and quicker resolution of consumer grievance. Assess installed equipment's health. You maximize utilization of asset of life. Minimize maintenance, capital and O&M expenditure, operational and maintenance expenditure. Okay, you focus the problem, identify the problem associated with the grid mechanism. Okay, and identify issues related to power quality, power management, and detect, reduce the electricity theft, which is one of the major concerns nationally, internationally. So we will go into details actually all these things. And what are the standards of smart meter? IS 16444, that is for smart meter part 1 and 2. IS 13779, this is for the static electricity meter. And 14697, AC transformer operated kilowatt hour meter, kVA or H. Okay, data exchange 15959. Okay, prepayment meter 15884 IS. Okay, IS 15707, this is for evaluation, testing, installation, maintenance of electricity meter. Code practice. This is how the standards of electricity meters have been evolved. And Indian system is now in a position to cater to your specific requirement with regards to operability, characteristics, focusing, functioning. We have discussed about the Indian standards. We will discuss about the international standards also. IEC 62056 series. In fact, this book is available now. It is available in internet. If you want, I can just post it to you through mail. This is a very, very important subject. Even all the specification, whatever is required for you, I think you can keep in your library, because you have to keep referring to what is happening internationally. Okay, so this is 62056 smart metering standards, and you have different applications for DLMS, device language, COSM, companion specification, object identification. Like that, you can see there are 61 parts running to about 3,500 pages. All these things are very important documentation for your upgradation of knowledge, and also not only knowledge, technology, because knowledge is linked to technology and it is linked to smartness. So that is how the smart meter is being discussed. Okay, smart meter functionality. Okay, what it does? It records consumption continuously and informs the head end system in predefined interval. What is head end system? Head end system is a computational mechanism which accepts the data from the smart meter, and it keeps the raw data, and raw data is sent to MDMS. MDMS is meter data management system. We will talk more about it. Don't worry about anything. For the time being, you understand the functionality. Okay, it enables bidirectional communication. It communicates information on daily basis back to the utility for assessing, monitoring, and billing of electricity. Okay, it provides online update to the user through web or in-home display to help efficient energy, so usage, and reduce bill. That is very important. Okay, prepayment functionality is a feature which is available in this smart meter today. You can use the smart meter as a credit meter or as a prepayment meter. And if you are using a prepaid meter, your efficiency of collection will be 100%. And naturally, the ATC loss will be very, very less actually. Keep in mind that. Theft detection and intimation to head end system. So this is how the meter functionality is being driven through. Okay. Further, there are major features and functions like what? Inbuilt communication, automated upload, metering data, ability to monitor near real-time critical data, and adaptability to multiple metering modes. Okay. Ability to ensure remote connection, remote disconnection of connected load to provide DSM, demand side management. Ultimately, what is your intention? You must manage your demand, particularly power demand, energy demand, in a scientific way. That is possible by virtue of smart meter. Okay, smart meter function. What it does? It collects the data, it communicates the data, it analyzes the data, and it provides a support for decision. It will not take any decision. Decision is you have to take. Okay, decision support. Okay, so this is a slide taken from LinkedIn very recently, I think probably in 2022 January, and this is one of the important slides which will give you what needs to be done as a multi-function. Okay, you can see here from the consumer and regulatory aspect, tariff, SLA. This is nothing but service level agreement. We will come to this actually probably tomorrow. Okay, information to customer. Okay, supply quality. That is, how the supply is, whether it is conforming to the standards of your international standards, that we have to see. Billing, if there is any dispute, and Street lighting, of course, this is something which is related to all other aspects also. Customer angle, from the utility angle, that is very important. From your angle, what is that you are looking for? Loading optimization, network planning, outage management, healthiness of the system, uh, supply quality. Okay, supply quality is definitely the prerogative, is a prerogative of the electricity board. Field team efficiency. Next, we will see government, particularly the future policy who will make on the renewable integration, because renewable energy is coming up very fast today. Sun energy, wind energy, okay, electrical vehicle, that is also picking up very fast today. And then petrol vehicle is being taken over by the electrical vehicle today, as you know. Okay, load growth forecasting, and DSM and EE is energy efficiency and demand side management, and the utility balance sheet, because finally you look at what, how much I have spent and how much I have gained. Okay, cash box, theft control, prepayment system, non-payment, disconnection, revenue cycle. Okay, so smart meter can also help in safety, load management. These two factors are very important: SAIDI and SAIFI, and power quality. What is this SAIDI? SAIDI is nothing but System Average Interruption Duration Index. What is this? This is nothing but total duration of sustained interruption divided in a year divided by total number of consumers. Okay. And what is SAIFI? This is nothing but System Average Interruption Frequency Index. What is this? This is nothing but total number of sustained interruption, okay, in a year divided by total number of consumers. You please keep this in mind. I will supply definitely this all this material, and then you keep rolling on this and then thinking on this, and this material is available to you to focus more about in the future actually. Okay, no issues. So what is smart metering and key differentiation? What is this actually? This is very important. So you can see here. So this is number of phases are there. 1, 2, 3, 4, 5, 6. This we call a hexagonal smart metering differentiator. Okay. So number one, we will start from here actually. Meter reading. Okay. See, you can see here. Optimized operational for distribution company. Okay. Next, real-time transmission of meter data. It is very important. It enhances the consumer satisfaction. Okay. Next, remote firmware upgradation. You can see here. Discom operations and maintenance time can be totally optimized by virtue of this. And you can go for NIC firmware. What is this NIC? NIC is your network interface card, which is nothing but your total system integration with which the whole activity is being driven through. Okay, this is important. First breathe and last gasp reporting. Okay, what is this first breathe? First breathe is nothing but it can be installed in the electricity meter to send a message to the HES data. Okay, first breathe means what? It is the when the meter is powered on. What is the last gasp? Last gasp is nothing but when the server, the current is cut off. Current is cut off. That is the last gasp. Like your breathing. Okay, same philosophy. Next, we will go to the event and logging. Like instant reporting of events, more number of events, revenue assurance for the distribution company, better planning for the distribution company. So you can see the Bureau of Indian Standard has defined the meter, which we have already seen, as the basic static meter with time of use register. That means time of use means what? You can schedule your loading pattern and internal connection and disconnection switch with two-way communication. That means to say the smart meter will have a TOD register, a internal relay, and also the communication. So this is the basic thing which we have driven through. What are the technology challenges? Number one, communication technology. Number two, apart from the communication technology, you can select the communication network on advantage and limitation. Okay, for example, you can select a matured technology, deployment, low capital expenditure, reutilization of the existing network itself as far as possible to avoid the capital cost. Okay, and then you can go for the next generation system, because we are now already in the 4G domain, and you explore the possibility of going to the next 5G level. Okay, dependency on the single communication system. Okay, and additional resources required to maintain efficient communication and safety for the tower, safety for the DCU. What's the DCU? Data concentrator unit, which we'll talk to you more about the DCU also, because that is one of the most important aspects in the smart metering philosophy. Okay, and also in the operation and maintenance. Okay, and also you will have some issues with regards to RCDC, that is, reconnection of meter or disconnection of meter. This is done automatically for your information. You don't have to go there. But these are all the challenges which you are facing actually hitherto. And now the solution is being given. These are all the different types of smart meters: single phase, two wire, okay, three phase, four wire, three phase, three wire, either with net meter or without net meter. You can opt for it because it is available as a choice. Okay, and then LTCT, that is, low tension CT operated meter. Okay, three phase LTCT operated meter. Okay, ancillary meters like, the individual feeder meter, boundary meter, bank meters. All these things are different types which are available today nationally, internationally. What are the technology challenges? Number one, upgrade of version. That is the billing system upgradation, integration with the legacy billing system. Legacy means old traditional system. Okay. Integration with non-standard billing system. What is non-standard? Which is not defined according to a particular feature of standardization. And lack of standard. Today, you have a lot of standards, but however, still, the standardization has to be firmed up for the policies. Okay. Billing system, you can size it in the sense, higher billing, lower billing, in the sense, the person who pay more, etc. Integration between the customer interface, that is, the mobile app and web portal. Integration with SMS, that is, the services actually we call payment gateway. Okay, and meter compatibility, regular firmware, we call the FOTA, that is regular firmware over the network. Multiple head end system integration for the radio frequency and GPRS meters. These are all the main challenges on the smart metering philosophy. Smart meter is a new infrastructure, right? Then what is this? What is this actually? This is here. Number one, quality and service. Number two, the pole and power line cable availability. This is important. Number three, binder management. What is binder? Binder is an open source web application for managing digital repositories. Okay, that means digital repositories means what? Based on the digital technology. Okay, and binders above 90% for achieve maximum billing. Who are paying more actually? You can focus on that. Timely pre-inspection of meters. That means, this is a very important factor. You have to focus on how frequently you inspect the meter and make sure that the meter answering all the requirements. Okay, deployment of adequate distribution company staff, and make sure that the old meter is taken away, the new meter is being installed, educate on the new meter, tell about the new meter. Okay, and also updating the legacy data. This is how the whole structure is given. Software infrastructure is the next important aspect. Billing system, you can always traditionalize, technology can be built into the billing system. Okay, and consumer profile, management of data, and timely update of MCO. MCO is movement control order. Suppose, the person changes his house. Okay, and also new builds a new house. Okay, and then how the power can be given to him, what will be the focus on that, whether the smart meter fits there, whether the communication is available, all these things will come into picture actually. Okay, mapping the correct network, automation, the process of master data synchronization, how you can synchronize the main data, adherence to window for binder opening and closing the smooth billing. Okay, and license upgrade and ATS for billing system. What is ATS? That is applicant tracking system, which is available in the internet. In the sense, you can track it actually. Just give your code, it can be tracked actually. Okay, weekly update on the legacy data. So this is how the smart meter, it will do what? Smart meter do not save energy. People do. This is very important. Their sole purpose is to change your planning and bring an awareness. It is hoped that the consumers will save energy through increased awareness of how much they use, and the estimated bills will be eliminated. So this is what it is. Right side, you can see a round smart meter. So smart meters do not save energy. This is a myth actually. Okay, you have to do it by using smart meter. This is what it is, right? Key benefits. This is one very important slide. Actually, you can see here the matrix has been drawn, taken from LinkedIn actually. Okay, so here you can see here, this is the impact of business: low impact, high impact. This is the time: long time, short term. You can see here the benefits section. Okay, and then here to the distribution company, these are all the main benefits. To the consumer, these are all the main thing. To the society, these are all the things. To the society is what? Efficiency of energy, emission reduction, employment for skilled resources, because it calls for communication engineering. As you rightly said, the importance of smart meter is convergent technology, electrical engineering, okay, information technology, communication technology, big data analytics, okay, and then finally we are also going into the domain of artificial intelligence also, so that you can incorporate what you want to do to make it more digitized and more technology oriented. So the benefits we have discussed, okay, accurate billing, expenditure reduction, monitoring of losses, high operational efficiency. Okay, you can have a proactive approach like what we are doing today, because you are getting training, and this trained you can definitely further you can train others actually based on whatever the material you have with you, and you can focus on what needs to be done. Asset management, okay, improve discom revenues. Okay, so these are all things which are all very important from the point of understanding the smart meter philosophy. Next, you can see here a picture. What is this? This is an IHD. What is IHD? In-home display. What is in-home display? Energy information display. What is energy information display? It gives you rate, cost, cost this month, estimated bill, days left in a cycle. Okay, how it will do? It will do by combination of the meter itself, because connected to the meter. And you can say, for example, while you are cooking, you can know how much dishwasher is consuming, how much fridge is consuming, because they're all kitchen items. Okay, how much your the heater oven is consuming. Okay, these things are monitored, energy monitoring. It will give you history, it will give you the energy, it will act as an energy manager, and it will message the center to make sure that what you require and what you have consumed will be known to you immediately. You don't have to wait for 1 month to get your bill made actually. Okay, there are two datas available today. One is the aggregate data and other is the granular data. Aggregate data is the data which is read once in a month. We call average data. Okay. Granular data is the data produced by the smart meter once in 15 minutes. We will see more about it. Okay. Don't worry. Next is automated meter reading. What is AMR? Because we have to spend some time here. AMR, advanced metering. Here, we have not the old traditional AMR. AMR, upgraded version, advanced version. Automatic meter reading system. It serves to read meters and convert the data stream into standard readable file, like what? CDF file or XML file. CDF file, common data format for DLMS meter, device language message specification. We will discuss those things. Don't worry. Okay. Basic building blocks of the electronic meter are what? External, built-in modem, mainly cellular. Okay, and also P2P or MP2PP. That is what? P2P is peer to peer, person to person. We call peer to peer. Okay. Next, MP2P, that is mobile peer to peer. Okay. Next, we will have MDAS. What is MDAS? Meter data counting or analyzing system. In the sense, it analyzes the whole philosophy with which it is possible for data acquisition. Okay, right. So this is the building block of AMR. You can see here the electronic meter is fitted here. GPRS, General Pocket Radio Service. This is AMR, internet, the cloud actually, and then it goes to the computer with a server. So this is how the building block of a AMR system is being driven through. AMR will have error-free fast track, on-demand reading, plugging revenue, outage management, okay, SMS-based alert system, okay. This is the messaging system we call, okay, and it will avert the breakdown and asset damage. It enhance the operational efficiency of the system, right? What are the limitations of AMR solution in whole current segment? What is whole current segment? The entire current is being passed through the meter. Okay. There are two things. One is whole current, other is the CT operated version. That is CT operated version is the version where it is operated through the current transformer. Okay. Here meter is read. Interoperability issue. Interoperability means what? The make of one meter should fit into the make of the other meter with other accessories. This is interoperability. No self-healing feature. That means self-healing is not there. This is the limitation. Self-healing means what? It heals on its own. If there is a power outage, it manages to go to the next feeder automatically. No remote manageability. Does not support value addition. Example, outage detection. Unable to support future needs. Okay. No remote connection, no remote disconnection. These are all the limitations, main limitations. So this is a typical smart meter, static meter. Okay. You have a current sensor, voltage sensor. The blue dotted line is an ASIC, application specific integrated circuit, which is a chip done on what we call the high-end technology. It has a temporal detection logic built into that, current selection mode, energy calculation unit, all these things. It will have an output like what? Impulse counter, okay, reverse polarity, earth fault. These things are given as a smart metering application. Okay, this is the typical block diagram. This is the block diagram of a smart meter. The upper portion is called metrology portion with measures. Okay, like active energy, reactive energy, apparent energy. Whole thing is measured on the board. Here, we have a metrology processor. Okay, it has a port and it has a connection disconnection switch. And also it will have a communication board. Communication board may be a hand based, NAN based, or LAN based. Okay, whatever it is. The WAN based. Okay, hand based is the home area network. Okay, NAN based is the neighbor area network. And this communication module can be interchanged to make sure that the meter works on the principle whatever you require. And this is the microcontroller where the power supply is there. This power supply we were discussing. This power supply is nothing but here. This power supply we were discussing in the morning, how you can optimize the power supply to make sure that the power loss in the meter is as low as possible. This power supply and this power supply together, you can focus on this, and this can formulate into a specification. LinkedIn. Okay, thanks to LinkedIn. Next, how the smart meter works. I think more or less we have discussed this. Not very complicated slide here. Okay. Smart meters measure energy consumption. The data is transferred via PLC. The data is collected to head-end system. The data is forwarded to IT system like what? Customer interface, distribution management, etc. Okay. The metering data used for billing. The end consumer receives bills. He pays either online or whatever it is. This is how this smart meter working philosophy is there actually. Benefits. As you can see, pictorially, I have made a slide actually to make you understand. LinkedIn, reduced energy bill, reduced meter reading error, reduced metering cost in rupees, dollars, whatever it is. Quarter hourly usage data, that means you can use it in quarter hour, that is 15 minutes data usage pattern on the computational system. Physical privacy, you can, this is very important. You can, the others should not know that what you are using. Okay, this privacy is definitely very important to safeguard. Fine. But when you click here, probably you will take some links also. I will send you all these slides, don't worry. And then prepayment option, you can either opt for prepayment or credit based system. These are all the major smart metering benefits occurring nationally, internationally. These are all the features of the smart meter. As you can see, there are 12 actually, because it records latest hourly usage, remote reading, remote connection, remote disconnection, bidirectional communication, visual display, meter setting reconfiguration, tamper detection data analysis, outage notification. Okay, prepayment option, this is an optional thing actually. If you buy a smart meter, it gives you the option to use it as a prepaid meter. Okay, time of use nothing but the system with which we are today facing a lot of problems. Morning 6 o'clock to 9 o'clock is the peak hour in the morning. Evening 6 o'clock to 10 o'clock is the peak hour. During that hour, if you consume more power, you have to definitely pay more. Load control, measurement of different parameters like active energy, reactive energy, apparent energy, okay, maximum demand, cumulative demand, so many parameters. Okay, fine. This is a pictorial representation of billing by smart meter. So how this particular thing is done without the meter reader? Your smart meter measures and records electricity usage, maybe every 30 minutes, every 15 minutes, depending upon the programming. Data is transmitted to the electricity distributor, who owns the and manages the grid poles, whatever it is. And then it goes to the energy provider, like consumption data is available to you via a web portal or in-home display. Okay, and then it goes to, you can monitor your household energy usage to help compare offers and better manage the cost actually. Okay, so these are all the benefits where you can get this reduced billing, real time feedback, more accurate bills, no more meter reader, reduce carbon emission, no more estimated bill. This is taken from SSC, from the LinkedIn once again, where you have total benefit for the metering philosophy as a whole. Regulatory standards are very important, but we are spending more time actually tomorrow. But however, this you should understand from the communication point of view. A wireless technology, that is radio frequency technology, to comply with the Indian WPC, that is Wireless Planning Coordination Wing, okay, that oversees the licensing and management of all wireless spectrums in India. Okay, so a WPC equipment type approval is required for utilizing the license free bands. There are license free bands today. For example, Zigbee band you can take 2.4 gigahertz, as well as 865 to 861 megahertz band. These are all what we call as the license free band. This is known as the ISM band vehicle. ISM means International Scientific Medicine. Okay, it's used for medical purposes. For information, the present relevant regulation is specified in GSR, that is Global Symposium for Regulators. Okay, and issued recently by the governmental agency. This you should understand to have some knowledge. Don't worry, and we will tell you more about this as we proceed further. Smart meters enabling a paradigm shift actually. How? From supply side management to collective supply and demand side management. So this is metering past, metering present, metering future. Here we can have, this is the pink line is the electrical connection infrastructure, pink line as you can see, and the dotted line is the communication technology. Okay, so past, present, future. You please make sure that you are focusing on these things. Here the high temperature superconductor is used to reduce the loss. Storage mechanism, you have the battery storage, hydrogen storage, and pump storage. So many things will come into picture. We will discuss, don't worry about those things. Distribution center, okay, industrial customer, industrial consumer, residential consumer. So this is how the philosophy with which this smart meter is going from what we call past, present, future technology needs. Okay, what is the architecture of a smart meter? The architecture of a smart meter is, for example, This is the architecture. A, meter. B, control, or we call load switch. C, data exchange protocol, metering protocol we call. D, communication. It may be a hand module, home area. It may be a WAN module, wide area. It may be a NAN module, neighbor area. It will go to the optical port to get the data. This is a sort of arrangement, to make sure that a side by arrangement in the case of failure, okay, communication may fail, then you can go for this. It will go to IHD, the in-home display system, and this is the head end system. This is how the smart meter architecturally it looks like that. And you can select, there are 6 or 7 architectures in the IEC documentation. Just I have taken one to explain actually. What is the Indian scenario? This is very important. Number one, Indian power sector is grappling with challenge of higher ATC losses, which has significant impact on the financial health of the utility. Okay, smart metering technology will help to reduce the losses by minimizing human intervention. So India has a vision of replacing around 250 million conventional meters and with smart meters. Further, this COVID-19 has reinforced the importance of smart meter deployment in India, considering the perceived benefits during the lockdown period. That is, improvement in billing, improvement in efficiency of collection, improvement in load management, remote connection and disconnection services, etc. So, some distribution utilities could leverage smart metering for proper billing and collection. Hence, the smart metering will be most imminent, most significant for our today's pandemic situation. And also, in future, this is going to rule over. Okay, this is how the now, next, and beyond. Okay, what are the key challenges? First challenge is inertia. That means, whether smart meter is required, whether it is useful, whether it is going to serve the purpose. Question is not asked because scientifically we have proved, technologically we have proved, all over the world about 400 million meters are working today satisfactorily. How it is working? Because it is technology. And then there are different models. What is this model? This model, there are different models which we will discuss, don't worry. There is first challenge. The second most important thing is that is, to understand, the electricity bill payment. That is, we have always had an issue with a large number of consumers who are not paying. So this is where we have to focus. Third important challenge is awareness and education and training. Lack of training is one thing which will create problem in installation, and also not only installation, maintaining, okay, testing, okay, and also integrated testing, which we'll talk in another 5 minutes. Don't worry. Okay, models. Which model is suitable? Which is very important? We will see that actually. Number one, this is known as boot model. Boot model is nothing but OPEX model. What is this actually? Build, own, operate, transfer. Boot. BOOT. Build, own, operate, transfer. This is very important because catch 22 that the discom have been caught in because of high non-payment. This has led to lack of revenue for investment in the distribution sector. The boot or OPEX model is essentially enabling the investor to invest in installing and operating the infrastructure and receiving the return based on that actually. India is planning 250 million meters by 2025. This is a very, very important message. Okay. Today, we have more than 2 million meters in India. And EESL, a governmental Ministry of Power, they are responsible for procurement and installation of these meters as in the Indian environment. So why the focus on prepaid meter? Because you can get electricity even for 20 rupees like your mobile charge. And 20 rupees, you use the electricity and forget about it. So this is how, it serves all mankind from glorious to the poorest. So like that, this is how the challenge is going on. Main challenge here, is the opportunity on the energy utility company. Okay. And you can focus on the installation, on based on the kilowatt, for example, kilowatt hour, based on the utility pattern, 200 to 500 kilowatt hours, 500 and above. Like that, you can plan and you can make a total technical engineering plan to make sure that the meters are installed in the correct installation networking system. Okay, that is what it is. Challenges: system implementation. Okay, challenge in replacing these meters: system implementation agency, lack of expert manpower. Okay, interoperability issue, that is, among various components, like, for example, meter interoperability. Okay, for example, if you take meter of X, meter of Y, meter of Z, they may not match each other. Communication, this is another important aspect. Head end system, software and hardware. MDMS, this is another software and hardware for the meter data management system. Billing application software for the customer management system. Okay, hybrid technology, like what? 4G, NB-IoT, is, I think I told you, narrow band Internet of Things communication. Okay, protocols, like, the head end system. Modality, non-availability of the high tension transmitter, this is another important. Today we are focusing only on single phase and three phase, particularly for the lower end of the application. For higher end, we have to think, because energy here, the revenue is more. HT energy revenue is more. It has to be designed actually. Okay, limited domestic manufacturing capacity, encouragement to new manufacturers participate for timely implementation, right? And here, very important is the implementation for conservation. Okay, number one, it provides TOD. Since TOD is there, that is a tool for the conservation. TOD is time of the day. Second thing is, it is a novel scheme with a prepayment option. That means to say, you can focus on this. Internationally, people have gone, like in South Africa, China, UK, Bangladesh, European Union, USA, they have gone into the smart meter, particularly on the prepayment option. Okay, today in India, I think probably about 20 utilities are using these meters without any problem, without any issue. So therefore, we have to make up our mind to make sure that technology-driven exercise is a very important factor to provide these operational characteristics. Okay? So this is the DT metering scheme using the smart metering philosophy. For example, this is the data concentrator. Okay, this can serve around 1,000 meters. Okay, one particular station can serve around 1,000 meters, and one concentrator under the transformer up to 1,000 meters. Each meter can serve as a repeater actually. Okay, so here A is nothing but, this is A. A is nothing but A1 plus A2 plus A3, where that is the reading of all these meters actually. Okay, fine. A1, A2, etc. And A is the data, A is the DT meter. So A is equal to sum of these things. If there is any sort of leakage, it will be immediately known. So this is the philosophy with which the smart metering arrangement for the LV transformer DT metering scheme is being driven through. Okay, integrated testing of smart meters. I am only covering a few things because very elaborate slides I have made. However, for this 90-minute presentation, I think probably another 15 minutes are left with me. I will try to finish and then we will try to answer your questions. Don't worry about it. So what are all the main tests that is done actually for the smart meter? For example, insulation, accuracy requirement, electrical requirement, electromagnetic compatibility, climatic influences, mechanical requirements. These are all some of the tests, which are done. We will just see the standard. The standard we have already discussed. 16444 is the standard, and 13779 is the digital meter standard. And for load switch, 15884, 2010 version, read in association with 2016. So that is how the standards are being talked about. This is how the meter will have this load switch. So load switch will be normally, we will show how the meter is tested in the integrated testing. Means testing of meter, testing of load switch also. In what position the load switch should be there, we will show in the next coming slide section. So it will have insulation property, EMC. Insulation property means what? High voltage test. Okay, and then impulse voltage test and insulation of the plastic parts. EMC test is electromagnetic compatibility, like EMI and EMC. Okay, this we will see radio frequency tests. Climatic, like hot, cold, humidity conditions we have to see. Mechanical property, like the vibration test, the shock test, and spring hammer test will come here. Electrical requirement, accuracy, starting current, power loss, it will come here. We will see, don't worry. Okay, so this is how the position of the switch is shown here. Okay, and impulse voltage. Okay, this is done in according to IEC 61000 4-5. AC voltage, insulation resistance. Okay, and accuracy test is done in the switch closed condition. Okay, accuracy, limits of error, meter constant, starting current, no load condition, ambient temperature, repeatability of error, influence quantity. So these are all the type tests done on the meter. And you can see in some cases we have the switch open condition also. Integrated testing will call for these things actually. Okay, power consumption, influence quantity, and you have the power supply management and self heating. All these things are done according to the clauses given in the schedule. And this is the test for other requirement, like fast transient test, immunity of electromagnetic discharge, immunity of electrostatic discharge. Okay, and then surge immunity, dry heat, cold heat, damp heat. All these things are done in different conditions of switch mechanism. Mechanical test, like vibration shock. Okay, accuracy, like the test before resistance to heat and fire. Heat and fire, because its plastic parts are used. The cover of the meter is polycarbonate. Okay, terminal block is the what we call the bakelite. Okay, for phenol formaldehyde. Okay, remote disconnection connection switch is also tested for the conformity. These are all other tests, like endurance test, line to voltage test, short circuit test, minimum switched current test, dielectric strength test. These are all the things actually. Okay, testing and validation process. What is this? Physical inspection, checking of power connection, testing of up circuit, power up circuit. That is, power up circuit is power supply, power consumption test, communication test, MDMS. How do you check MDMS? By software and hardware checking, meter data management, by data analytics, connectivity check, like head end system, validation of software availability at customized ERP package, enterprise resource planning, particularly on the SAP technology. We will talk more about it. Testing process. Okay, integrated domain system. This is the validation. What should be done for validation? Validation is a process to ensure functioning of the system to meet the objective without failure or malfunctioning in any field condition, and to ensure the return on investment and no regrets about technology. Validation is very important, and this is taken from LinkedIn. I think 2 days back, this had appeared in LinkedIn. So validation of smart meter is done basically with regards to what? With regards to the guaranteed technical particulars. The GTP is available with you. Guaranteed technical is available. It is a signed document. You check with the representative whether the voltage level is okay, current level is okay, your communication system is fine, error is fine, whether it can be validated, whether MDMS data is okay. So those things are nothing but your validation. Validation for the communication, validation for the total structure, the total package is done on the smart meter. Okay, I think I have concluded this session well in advance to make sure that we answer certain questions. Smart energy meter being a crystal eye for consumer and utility, its quality, its reliability is beyond doubt. Product quality and reliability is needed to be assessed as per the respective protocol standard. So modernization, innovation in smart energy meter has given a total boost for the utility and consumer, so that it will go further to gain momentum achieved. Test is important to make sure that the product is in line with your requirement, to ensure proper compliance, to ensure whether it is okay in all arrangements. Go to a particular laboratory like CPRA Bangalore, BHEL, RDA, NPL, National Test House. These are all the agencies which will give you a lot of the test data, test inclusion. Okay. Smart meters are the backbone to a new digital environment, and it will enable renewable energy sources, technology. Okay. So, to benefit from smart meters and support your organization transition to net zero, which is the focus mantra of our honorable respected Prime Minister, and it is nothing but we have to honor it from the smart meter and AMI. So, this is what presentation is about, particularly with regards to what we call the smart metering philosophy. Okay, so very nice to have you on the board actually to see that.
Sir, 1 minute, sir. I will ask the participant whether they have any doubt, sir. Bala, sir.
Yeah, yeah, you can ask, you can definitely, anybody can ask any question related to the presentation today.
Sir, you are joining smart meeting? Yes, sir. Tell me, sir, your doubt, please.
If you are not in a position to ask a question, you can chat it. I will answer that at leisure also. That is also possible. But
Sir,
only thing is, you have to clarify your doubt, having come, all the way to make sure that what has been taught, whether it is in line with your requirement, is to be known actually. Okay.
yes, sir.
Okay.
Sir, tell me, sir. I will share. I will. Sir, mic is connected with this camera. Okay. You can talk here. I think.
Everyone, sir, thank you for your wonderful lecture on this smart challenges, sir. So we have few notes regarding smart challenges. So we have developed around 8,800 smart meters in our utility.
Hello.
Yeah, yeah. We can see that the communication of the meters to the hidden system is not more than 70% at any point of time. We have a different mode of communication to the smart meters to the hidden system. We have the hybrid communication like RF mesh with PLC, and we have GPS communication from meters to hidden system also.
Okay.
We can achieve the communication more than 70%. And we are facing a big challenge on this that if we just switch to the prepaid mode, then in case of any payment through online system by the consumer, and in case of failure of communication during that time, how to address these challenges with the operation of the smart grid system?
Yeah, yeah, yeah.
So second question is that we have the PLC of metering, the speed defined meter is there, which is around 50 minutes. We have the predefined meter communication to the meter system. But I find that most of the times the communication from the meter to the meter system is getting failed. So we don't have the real-time data from the meter to the meter system also. So thereby we are losing the accuracy of the metering and to go for the accurate system also. So as per this RDC scheme, we need to have the monitoring of the meter system. That is a quarterly basis, monthly basis, and daily basis also. So in the event of the failure of communication from the meter to the system, it's not at all possible to achieve the goals of that reduced losses. So do we have any kind of a reliable and the supportive communication channel for the headed meter the health system so that we have the at least nearby real-time communication that is almost 100% of meter data communication to the health system. So there is a whatever requirement. And we are also facing a challenge that what should the mode of communication channel from the meter to the health system. So we have faced a lot of problems while selection this mode of communication. So how to address these challenges that we require from your side, sir?
Okay. So very, very valuable question. Very nice question you have asked, from the point of your utilization. Definitely. You see, most important factor here in the smart meter is the communication technology. What is to be adopted and what is to be selected and how optimal it is and what are all the main objectives of this particular thing is to be understood properly first. Okay. Anyhow, communication technology we are dealing separately. Particularly, I think tomorrow I think I am taking up communication technology also. We will discuss more about the communication problems that is being faced in the industry today, particularly with regards to the integration of communication with the metering philosophy. That is one major challenge which is available today, which is a technology problem, for the communication engineers also. So your main question is how the technology is useful for getting the data, number one. Number two, most important factor here is optimization of the data. Number three, how useful this particular thing which can have an impact on the overall scenario of the metering application. So these three aspects, we are covering separately. When we go to AMI, we will address these things, particularly the mesh technology, the RF technology basis, and international cases also I am giving, so that you will be in a position to understand more about the community. Because today, what I have drawn is a basic picture of a smart meter, particularly with regards to usability, accountability, adaptability, acceptability, and also some of the main testing, etc., which is being driven through. However, your question is very valid, from the point of integration of the total solution for the smart metering philosophy, which we will definitely tackle. And we have noted down the if you can clarify, if you can write down the question and chat it, I can give you a paper on that by tomorrow. That is not an issue. Okay. So you can send, the request through Senthil Kumar or through the chat box. I will analyze the question basically and give you a sheet of paper tomorrow that can be used, for your integrated solution also. Is it okay, sir? Thank you so much. Any other questions? Hello?
Yeah, one more question, sir. One more.
Sir, he is having doubt with one more question, sir.
Yeah, please.
If there are lots of data from the meter to the NL system, so do you have any tips whether to is a number of the network error or is it not of the metering connection was defective? Because when the network operator is taken up here, he said that the network is always available from the 24 hours, but there is maybe issue with the meter device. So when I open the meter device, there may be a connection model failure also. So how to recognize in which time the connection is getting failed, like there is a meter connection one failure or network failure or hidden system failure, like we have a hidden system like power system, power server also. So how to recognize all of these parameters, which system is responsible for various data from meter to the hidden system?
Yeah. Okay. I think the second question is linked to first question only, because they are all integrated solutions actually. See, as I have already told you, the smart meter will always, deliver you not only the energy consumption pattern, but there will be a mobile alert to you to make sure that how much consumption has happened during the last 15 minutes, last one day, last fortnight, last 1 month, etc. So it will also give you a profiled history with which, it is possible for you to assess what needs to be done to strengthen, where exactly the strengthening is to be done. For example, whether it is the communication system failure, whether it is the meter failure, whether it is software failure, whether it is operational failure, all these things must be locked down actually. And that can be done only by mobile app. In the sense, you can get the data, you can analyze the data, you can forecast the data, and you can definitely make a plan for that according to what is being used and what is being highlighted actually. Okay, so this philosophy also we will try to tackle it. But however, I would like you to give these two questions also in the form of a writing, so that we can generate a paper for you to make sure that it addresses all your requirement. Okay, thank you so much. Very nice of you. Good question, good interaction. So we will join here. If there is no question, we will join here after 15 minutes for the next presentation. Okay?
Okay, sir. Any doubt? Okay, sir. We will join after 15 minutes, sir.
Thank you so much. Very nice of you.
Thank you, sir.